Okay guys, so in this lesson we're going to take a look at how to solve exponential equations. So we're going to utilize our knowledge of natural logs and logs, and that's how we solve exponential equations, okay? So anytime there's a variable in the exponent, we're going to follow this procedure. So what we do is we natural log both sides. When we natural log both sides, we take the exponent, we bring it in front, and we natural log the other side. So if I'm going to solve for x, it's being multiplied right here, so I'm going to divide. So natural log of 30 over natural log of 3. Now I'm going to put that in the calculator, and I'm going to go natural log of 30, close my parentheses, over natural log of 3. Okay, and I get 3.096. And that's all there is to this. Okay, make sure you go at least 3 decimal places. Next one, we're going to isolate the exponent first. So we're going to do 10 to the x is equal to 38. And once I've isolated the exponential, I'm going to natural log both sides. So I get x natural log of 10 is equal to natural log of 38. We're going to divide both sides by natural log of 10. So we get x is equal to natural log of 38 over natural log of 10. Okay, I'm going to put that in my calculator. And I get natural log of 38 divided by natural log of 10, close parentheses, and then I get 1.580. Okay, next one, we're going to isolate the exponential, so we're going to subtract the 14 to this side. So we get 5 to the x is equal to 7. Okay, just like we did before, we're going to natural log both sides. When we natural log, we bring the exponent in front. Okay, so to solve for x, we're going to divide both sides by natural log of 5. So x is equal to natural log of 7 over natural log of 5. So we do natural log of 7, close parentheses, over natural log of 5, close parentheses. So we get 1.209. Okay. This one, we're going to subtract 4 first. Okay, so 19 minus 4 is 15. Okay, now I got to solve for the exponential, so I got to isolate it. So I'm going to divide both sides by 3. Now, an important point here is you can't distribute the 3 to the inside. Okay, so this is going to be 1/2 to the x is equal to 5. Now, like what we did before is we're going to natural log both sides, so we bring the x in front. And we get natural log of 5 on the other side. And then we're going to divide both sides by natural log of 1/2. Okay, so put that in the calculator. Natural log of 5 over natural log of 1/2, close parentheses, and you get negative 2.322. Okay, next one. So this is a little bit different because we don't just have a x in the exponent, we got a 4x, but it's still the same exact procedure. So we're going to take the exponent, put it in front, 4x natural log of 2 is equal to natural log of 3.6. Okay, so there's multiplication going on right here. So what we're going to do to solve for x is we're going to divide everything that doesn't have an x in it. So it's natural log of 3.6 all over 4 natural log of 2. And we put that in the calculator, make sure we use parentheses correctly. Okay, so it looks like that. And we hit enter and we get 0.462. Okay, the next one is going to look a little bit different because we have an x plus 4 up there. Okay, but it's still the same exact procedure. We're going to take the exponent, we're going to put it in front. Natural log of 19 is equal to natural log of 3. Now, it's important to remember that natural log of a number is still a number. It's a decimal, okay? Now, you might be tempted to distribute that natural log of 19 out to both of these terms. It's actually better if you don't. It's better if you divide it out, okay? So it's being multiplied by this whole term, so we're going to divide it out. So we get x plus 4 is equal to natural log of 3 over natural log of 19. Now, to solve for x, we're going to subtract the 4. And so we get natural log of 3 over natural log of 19 and minus 4, like that. Okay, next one. We have to isolate the exponential. So we're going to subtract the 5 first, like we're solving a regular equation. So 17 minus 5 is 12. Now, there's multiplication going on right here, so we're going to divide. And then I'm going to solve for the x. So I'm going to take the exponential and put it in front, natural log both sides. So x is equal to natural log of 4 over natural log of 5. Okay? So natural log of 4 over natural log of 5 is 0.861. Okay. Okay, on to next page. So this one looks a little bit different because we got e's involved, but it's still the same exact procedure. We have to isolate the exponential, so we're going to divide both sides by 500. So we get e to the 0.3x. 600 divided by 500 is 6/5. You cancel the zeros. Okay, so what we're going to do from here is we're going to natural log both sides. We bring the exponent in front. Natural log of e is equal to natural log of 6/5. Okay, now if you remember, natural log of e is 1. Okay, and so what we're going to do is just divide by 0.3 and we'll get our answer. So natural log of 6/5 divided by 0.3. So natural log of 6 divided by 5 divided by 0.3. Make sure we're using parentheses correctly. So 0.608. Okay, now we're going to start getting a little bit more interesting here. So we have two exponentials going on, and they both have an x and plus or minus something else in the exponent. So our procedure is still the same. We're going to take the natural log of both sides, and we're going to bring the exponent in front. Okay, so we have that right there. And what we do is we're going to have to distribute on this one. It's going to look rather crazy. So we get x natural log of 5 minus 2 natural log of 5 is equal to 3 natural log of 3x and then plus 2 natural log of 3. Okay, from there we're going to collect all our x terms on one side. It doesn't matter which side you're going to move it to. I'm going to move my x's to the left side. Plus 3 natural log of 3 x is equal to 2 natural log of 3, and then I'm going to move this 2 natural log of 5 to the other side. Okay, now the left side has an x in common, and that's what we're trying to solve for. So we're going to take that x, factor it out, and these are probably as long as they get whenever we're dealing with exponentials. Okay, so this x is being multiplied by this whole parentheses, so we're going to divide it all over. So x comes out to be 2 natural log of 3 plus 2 natural log of 5 all over natural log of 5 plus 3 natural log of 3. Okay? So we are going to put that in the calculator, put parentheses around the top. So 2 natural log of 3 plus 2 natural log of 5, close parentheses, divided by natural log of 5 plus 3 natural log of 3, close parentheses, like that. Okay, so you should get 1.104. Okay, and that is how we deal with this type of question. So the next one is going to be worked in a similar fashion, and I'm just warning you, I probably will put something like this on your test. And the first week of calculus, you're going to have a test that looks like this also. Okay, so what we're going to do is we're going to take the exponent, bring it in front. Okay, and then we get 2 minus x, natural log of 1.7. Okay, so we're going to distribute like we did in the last question. So we get natural log of 0.3 plus x, natural log of 0.3 is equal to 2 natural log of 1.7 minus x, natural log of 1.7. Okay? We're going to collect all our x terms on one side, so I'm going to move my x term over here. So it looks like that. And then I'm going to factor on x. Okay, so once I've factored out my x, I'm going to divide it over to the other side. So I get x is equal to 2 natural log of 1.7 minus natural log of 0.3 all over natural log of 0.3 plus natural log of 1.7. Okay, and that is our answer. So we're going to put it in a calculator. And you can leave it in that form, or you can do it in decimal form. Doesn't matter to me. Minus natural log of 0.3. Okay, and divided by natural log of 0.3 plus 1.7. Close parentheses. Oh, natural log of 1.7. Okay, so again, negative 3.364. Okay, so the next type of questions are dealing with factoring, okay? Now, if I was to make a simple substitution to where I substituted u is equal to e to the x, it would make it a lot easier to look at, okay? So, remember, if I was squaring e to the x, it would be a power to a power. So I would be multiplying it. So anytime you see e to the 2x, that's the same thing as e to the x squared. Okay, so this is u squared minus 5u plus 4 is equal to 0. Well, we should know how to factor that. Should be really good at factoring that. So this should be u minus 4 and u minus 1 is equal to 0. Okay, now what I'm going to do is I'm going to substitute my u in there, and I'm going to have two equations that look like this. Okay, so I'm going to go out to the side and work those. E to the x is equal to 4. So if I solve for that, x natural log of e is equal to natural log of 4. Natural log of e is 1. So x is equal to natural log of 4. And if I say e to the x is equal to 1, natural log of both sides. Natural log of 1. Okay, natural log of e is 1, natural log of 1 is 0, so we get x is equal to 0 also. Okay, natural log of 4, if you put that in the calculator, is 1.386. Okay, and you could have left it as natural log of 4, that's fine with me. Okay, the next one, e to the x. You have an e to the x in both terms, so I'm going to factor it out, my GCF. and I get x squared minus 3 is equal to 0. Now, important to note, e to the x will never equal to 0. Exponentials will never equal to 0. And I think I wrote that somewhere in the previous notes. So anytime you have an exponential, it will never equal to 0. If you go back to your graphs, we notice that there's a horizontal asymptote for e to the x as it goes all the way out to the left. So it will never approach 0. And then I'm going to set the other parentheses equal to 0. X squared minus 3 is equal to 0. Okay, you can either do difference of squares or you can move it over and solve. So I get x is equal to plus or minus square root of 3. Okay. Don't forget your plus or minus. Anytime we take an even root, we have to put plus or minus. Okay, this one right here is a little bit tricky because you got an exponential and a fraction, that sort of thing. So in order to make this look like something we've already done, we're going to multiply that to the other side. So we get 400 is equal to 350 times 1 plus e to the negative x. Now, what I'm going to do is I'm going to divide this over to the other side. 400 divided by 350, let's convert that to a fraction, is 8 over 7. Okay, so we get that. And then I'm going to isolate the exponential, so I'm going to subtract 1. So I get 1/7 is equal to e to the negative x. Now, to solve for the exponent, I'm going to natural log both sides. So I get natural log of 1/7 is equal to negative x natural log of e. Okay, natural log of e is 1. And I'm going to solve, and so x comes out to be a negative natural log of 1/7. And I'm going to put that in the calculator. Okay, it's 1.946. Yep. And last one. This is another factoring one we're going to look at. So these do show up in calculus. That's why I kind of revamped it, this lesson a bit. So we need to make sure we know how to factor this stuff. So like in the previous problem we did, we're going to say u is equal to e to the x. So we get 2u squared minus 7u plus 3 is equal to 0. Now I could do PSF on this, or I can factor it mentally. So 2u and u. Factors of 3 are 3 and 1. A minus plus factors to a minus minus. And just to check myself, my outer plus my inner give me a negative 7. Okay? So I'm going to substitute my e to the x back in. Okay, and we're going to set each one of those equal to 0. So 2 to the e to the x minus 1 is equal to 0. So I get e to the x is equal to 1/2. And to solve for that, I'm going to natural log both sides. Natural log of e is 1. Okay, so natural log of 1/2 is negative 0.693. Okay, and then this other equation over here, e to the x is equal to 3. Natural log both sides. Okay, natural log of e is 1. So we get x equal to natural log of 3. And natural log of 3 comes out to be 1.099. And if you want to truncate your decimal places, so truncate means that I'm just going to write the first 3 decimals that appear on the calculator. That's fine with me. It's not going to make really any sort of difference in your answers. Okay? So this has been solving exponential equations using natural logs. If you come along, another teacher teaches you to use LOG, that's perfectly fine with me. It works the same exact way. I was just taught to use natural log, so that's kind of what I stick with. So it's all the same thing. as long as you use log on both sides. Okay? So thanks and have a good day.